It's kind of funny. Marcus just did the whole presentation about artificial intelligence, talking about Anthropic Claude and whatnot. The only thing I'm going to tell you guys about artificial intelligence is that the title and the abstract actually came from AI. So everything else in the talk has nothing to do with it. Marcus already talked about me, one of the founders of LASCON. I absolutely love this conference, huge supporter of it. They do amazing things. Please give the conference a round of applause. They're awesome. I was also on the OWASP Foundation Board of Directors for a number of years and whatnot. So what we'll cover today, a lot of stuff having to do with dependency management and how to build an SBOM. And kind of how this whole talk got started. So Marcus mentioned SimpleRisk. SimpleRisk is a free open source tool for governance, for risk management, and for compliance. And it was something that I actually did not create to be a product. I actually wrote for myself. I was running the security team at National Instruments at the time, a big company based here in Austin. And my VP came to me one day and she said, "Josh, I heard about this risk management thing. Can you figure it out for me?" And I was like, "Yeah, I can do that." So I did a lot of research. I came across the NIST framework for risk management. And I was like, this is what I want my program to look like. But the piece I struggled with was the tool set. I used Excel spreadsheets. I used a custom Lotus Notes database for a little bit. And eventually I kind of realized that this all sucked. And I wanted to write something that did risk management. Well, first I tried to buy a tool. I told my VP it was $500,000 and she laughed at me. So I ended up writing something. And I give you that backstory because I think it's really important because it demonstrates that sometimes software that becomes enterprise software comes from nowhere, right? It's an idea, and it was an idea created for one person that probably didn't really care about the security aspect of it initially because they were the only user of it. And way back when I first released SimpleRisk, was 2013. It was at the B-Sides Austin conference here, and just to give you guys some metrics here, the bundle size, if I took all the code in the entire thing, it was about 92K. There were 18 PHP files in there. I had a few JavaScript dependencies, jQuery, that kind of thing. Didn't have any PHP dependencies. Everything was self-written. And the dependencies were kind of spread across 2 different locations. And at that scope, it's relatively easy for us to manage something. But it's probably worth knowing that even in that version, we still had dependencies. I created a JS folder, I dumped my JavaScript in there. I created a CSS folder, I dumped them, the CSS style sheets into there, and I never gave it another thought. Well, I gave it another thought, but I didn't at that time, right? And so I kind of looked about a year or so later, in 2014, and the dependencies had actually tripled when I looked at this guy. So less than a year later, we have a 576 kilobyte file, 56 PHP pages, 8+ JavaScript dependencies, 2 PHP dependencies now, so we went from 0 to 2 there. And now we have 3 different locations for all these dependencies. And hindsight is 2020. I'm going back and I'm looking at these bundles from way back when. I didn't realize at the time the problems that I was creating, the challenges that I would face later on. So now we fast forward from 2014 to 2021, and all of this stuff finally came to a head for me. At this point, just shy of 8 years of working on SimpleRisk, the bundle size was now 9 megabytes. I had 285 PHP pages, 27+ JavaScript dependencies that I counted, 5 PHP dependencies across 5 different locations. I counted 3 different versions of jQuery in 2 different locations in the product, including a version that was over 6 years old at this point that was actually in a JS/old directory. Why I did that, I have no idea. But you see what happens here, right? We start with good intentions, we create something that works, and we go, all right, it works. What else do I need? And at this point, we had customers. We had people that were using the tool, paying us for the tool. And I started to think, like, this isn't right. We have to do better. So, the recognizing the need here, just you can look at this chart and you can see at our rate of growth, the storm was clearly coming. We only had one CVE issued against us, but the growth, the dependency sprawl, was really exposing us and our customers to risks. So we needed to address that, and of course, who puts a 6-year-old version of jQuery in an old directory, right? And this package wasn't actually being used for anything. That's why it was in the old directory. But what if it was, right? What if we actually were using that? What if one of my developers went, oh, yeah, we should use that. That's the jQuery I should use. So apparently it was me. But I started thinking back to some of the speakers that we've had here at LASCON, and we've had some amazing speakers here at LASCON over the years. One of the guys is Joe Jarzenbeck. Joe, back in 2013, so the very first LASCON we ever had, he said 44% of known breaches come from vulnerabilities that are 2 to 4 years old. Right? Joe is predicting the future demise of SimpleRisk here. I should have listened to him way back then. We had a really smart guy named Jeff Williams. So Jeff talked about how software should be given security nutrition labels, just like a box of cereal does. And Jeff, another former OWASP board of directors member, he's talked on this stuff for years and years. And I probably should have listened to Jeff, right? He talked about this idea of a SBOM, or a software bill of materials. He said it's a list of components that you include in your software. And you could use this data to find vulnerabilities. You could look for license issues. It really enables organizations to treat software with known vulnerabilities like they would a 1,000-calorie snack, right? Proceed with caution. You're not going to eat that 1,000-calorie snack. As a security practitioner myself and former OWASP board member, I've always held it as our top responsibility to ensure the security of our software. And while this type of transparency isn't common, even today, even by today's standards, it's an opportunity for us to demonstrate that we're a leader in this field. So as you guys are going through here, think about that. Think about the changes that you can make in your organization to be viewed as a leader in your field. So when it comes to laying the foundation, these are kind of the first steps in terms of creating the SBOM. And we'll go from what I showed you here, which is really crappy dependency management, old versions of jQuery and JS, old directories and whatnot. And it's worth knowing this is not going to happen to us overnight. We start off and we have to figure out where all of our dependencies are. What's the location? What's the version of the software that's running? Licensing. A lot of people don't realize, like, open source, there's like 10 plus different common licenses for open source and a whole bunch of non-common. Talk about jQuery, we had 3 different versions of jQuery. Why? Right? We need to be able to eliminate these duplicates. Creating consistency with how they're managed. How do I update that version of jQuery? How do I update my other dependencies in the software? How do I know when they change a version of one thing to another version and they change the licensing? We've had that happen multiple times. And then how do I automate this process so that I'm not having to go and like manually review every single file that's out there? So I decided we can create an SBOM. We will build an SBOM, and our first SBOM looks something like this. It basically had a list of the PHP libraries that were included in SimpleRisk. Pretty simple, at the top I just said, hey, SimpleRisk core is licensed under MPL 2.0. Then I went through and said, here's the PHP libraries that we use in SimpleRisk core. And I mean, it's not a huge list. It was pretty easy for me to put together because I knew all the things that I had used, but it provides some value. Limited value, but some value. And here's the list of all the JavaScript stuff that we're doing. And then I even went a step further and I said, all right, there's some control frameworks that we provide for our customers, and here's the licensing for those as well. And by the way, we have these extras, which are like plug and play modules. It's how we make money. And here's a few things that we include in there that goes above and beyond that SimpleRisk core. So these are the paid for features and how those are included in the package. So it's a start, right? We have something. This first version of our dependencies includes the what, but doesn't really have the where. And the files are still in all these different locations, and we need some way to manage our dependencies. We need to be able to say, This is the thing that's there. Here's the license. Here's where it's located. So we build the walls. And if you go and you look on Wikipedia and you say, show me package management systems, it gives you actually a really nice list. And it breaks it up by what dependency management tools are out there for different environments. We use PHP, but maybe you use Java or C or whatever. Here's a list of lots of different programs that can help you to manage your dependencies. And the thing that we gain from doing this is that instead of having our files all over the place in a bunch of different locations, is we kind of have this standard way to include all the dependencies in there. We can aggregate them all into a single common location. And we can even do things like specifying the version and tell it just use the latest version of this dependency. And even better, one command can update all of the packages that are out there. So instead of searching each individual thing for like a license file or something like that, we just have it all in one place. Everything deployed to a common location, the versions are tracking, the updating is super easy, and the licensing is easily identified. We now gain some control over the packages that are out there. So we kind of move into 2021, March. And in March, the March release of SimpleRisk, we moved 6 of our major PHP dependencies to be managed through a dependency manager called Composer. PHP Composer, it's you basically tell it, here's the packages that I want to include. It goes out and pulls down the versions, either the specified versions or the latest versions of those different packages, and then it puts them into a directory that you specify in there. And there's lots of other cool capabilities. You can have it run scripts, copy files, things like that. So if you want like an htaccess file that disables access to a certain directory, you can do that through Composer, all sorts of things like that. But with this release, we moved those 6 dependencies into Composer. It's a start. The bundle at this point is about 20 megs, so we've actually gained 11 megs since the previous count there. And we're at 549 PHP pages. And that screenshot there is an example of one of these Composer files. So it's super simple. It just says require PHP version 7 in this case. You wouldn't want to do that today. We had Font Awesome, we had high charts, we had Laminas Escaper for HTML output encoding, and a couple other things that were in here. That Font Awesome is actually a really interesting one. I mentioned earlier that we've seen licensing change as we go. This is one of those packages where we saw license change. What they had in version 6 of the Font Awesome library was essentially an open source license. When they moved to version 7, it was actually no longer an open source license. And so we've seen TinyMCE was another one where we saw that kind of thing. So tracking the licensing that's involved is a must-have in these situations, especially when you tell people that you're open source, but then you're including components that aren't open source. That can be a huge problem and open your customers up to legal liability. So our SBOM at this point kind of evolved. I started looking at how do I give customers some idea of what we know, what we don't know, provide them with some insight into what we're thinking about these different things. And so I had this color scheme. And my color scheme was basically green if it's automatically managed via Composer, because those are things that we have good software dependency management under. They're yellow if it's something that we had to like manually manage, and it was red when it was a component that was problematic. So if we had like an old dependency, something that's no longer supported, that we needed to update to a new version or just replace altogether. We've had that happen on a number of different packages where they were obsoleted, end of life. Then we would mark those as red. And so this color scheme allows us to show like, what is the state of these things? And customers can look at that and go, oh, well, these things are under management. And the goal is to get to 100%, but that's obviously not going to happen right away. It takes a little time. The other interesting thing here is at this point, we're now including the location information. and the license information for all of the packages, including the ones not managed by Composer, which includes all the JavaScript. So you can see here we have a column for the package name. We have a description of what the package does. We have the location that you can find these files in, and then the license and usually a link to that license. So it's really easy for us to evaluate this and go, oh, these are the things that make up SimpleRisk. Here's where I would find that stuff if I wanted to validate that. And I'd even add another piece at the bottom to communicate intent. Our goal here is transparency. We want all of our customers to be able to see all the information and make informed decisions. And this kind of gave us a way to communicate that intent to the customers. At the very least, none of these were like gotcha moments where they send us a ticket and be like, hey, we discovered you have an old version of Duo on your system. We'd be like, yes, we know, it's documented here. Here's the description of why we need to work through this. So customers could see where the issues were and that we had a plan to actually address them. And we even provide kind of a risk assessment and justification for how we're prioritizing them. So Duo, as an example, they actually obsoleted this old version called Duo MFA. They created a new version called Duo Universal Prompt. And we basically needed to consider how do we move, or do we move in this case? And eventually we decide, no, we're going to axe support for Duo because we have other methods for doing multi-factor authentication. So when it comes to JavaScript, Composer would work for some of the JavaScript dependencies. There were Composer things there, but Composer is really meant for PHP. It was really intended to manage those PHP dependencies. And as it turns out, most of those JavaScript packages, we were actually able to manage them via another tool called Yarn. Yarn is primarily for like Node.js, but you can use it to say, here's the dependencies that I want. They're JavaScript dependencies. And it does essentially the same thing as Composer. It says, okay, well, let me grab the latest versions. Let me stick it into this common directory. I'll give you the version numbers, the licensing, things like that. And so at this point, we're getting a little closer. We're able to see the package name, description of what the package does, why it's included in here, the location where it exists, the license that it uses. And I can easily tell every single one of you which packages require manual management, because we haven't gotten them into the dependency manager yet. I can identify licenses that conflict with our MPL 2.0 license, but it still wasn't perfect. We're still creating this manually, which sucks. When I say we, I have a guy in Malaysia who I would be like, hey, Prem, I need you to go through all the packages and update the versions. But it takes time. It was a manual effort. We're getting closer. So if you've never heard of Dependabot, it's a really cool feature of GitHub. Dependabot will automatically scan your dependency files. So if you're using something like a Composer, Dependabot can actually look at that Composer JSON file and understand these are your dependencies. These are the packages that you include in your program. And because it now knows what dependencies are included in their versions, it can give you alerts for vulnerabilities. So actual alerts from vulnerabilities not too long ago. It was really fortuitous that I actually received these notifications in PHP spreadsheet while I was putting this presentation together. I'm sitting there working on it, and it's like, hey, PHP spreadsheet, need to update to the new version. I'm like, cool, let me screenshot that so everybody can see this. This is what we're driving to, right? We want to be able to have automated notifications of the problem so that we can fix them. So the next time I roll a SimpleRisk release, I can make sure that I upgrade to the new version of PHP spreadsheet. Now, it'll even create pull requests. So in our GitHub repository, it will tell me, hey, PHP spreadsheet, this is the version you're running, here's the latest version, here's the PR that will give you the new version of this particular package. So it will help us to, it will guide us to, here's how you do this. Here's the next step in the process. Now, at this point when it comes to the SBOM, I kind of alluded to us still having a number of issues. Our dependencies are manually managed, right? We have dependencies of dependencies. Oftentimes the software dependencies that we're including in our package, it has its own dependencies, and we have zero way to track that. The process is manual, and as a human, you can kind of look at this and go, okay, I get what they're doing, but a computer can't read that. A computer can't look at my color coding and goes, I know exactly what Josh is thinking there, right? We need a more programmatic approach, and this is really where the SBOM comes to play. So we kind of look at the CI/CD pipeline. And our CI/CD pipeline for SimpleRisk is essentially broken down into two pieces. We have the automated validation, which uses GitHub workflows, and we have the deployment side of things. So when we release a new version, deployment goes and builds all the dependency stuff and pulls it all together into the bundle and gives us release information that we publish out to our customers. So automated validation happens with every pull request that a developer commits to our testing environment. It leverages those GitHub workflows. Its goal is really to ensure that there's no code issues. So we do security vulnerability validation, we look at licensing, we have a list of acceptable licenses, and if it doesn't match one of those licenses, it throws an alert. So we know if a developer included a license that is not acceptable. And we can even look for quality. So my most recent hire was actually somebody who's building out automated QA, doing validation of all the functionality. So when we release a new feature, we know all the old features still work. The deployment pipeline side runs in Jenkins, and it handles the actual release process. So it essentially does anything other than publishing the SBOM at the deployment stage, and anything after that would be too late for action. So we do it as part of this kind of automated validation phase. So here's an example of the GitHub workflows. You can see the list of workflows that are run each time a PR is committed against the testing branch of our code repo. And each of these actions is essentially created by adding a YAML file into, there's a .github, so it's a hidden file, a hidden directory, /workflows. And so if you put that into your repository root, you can create all the different rules for your workflows. This particular example, or the next example I'm going to show you guys, is of automating checks to approve open source licenses to ensure the developer doesn't add dependency that doesn't follow our standards. So you can see how simple this example is. It's not a lot of lines of code. There's an on section. That on section defines when the action runs. So in this case, we're running on pull requests to our testing branch. There's a job section, which tells it to use a container with the latest version of Ubuntu. And then it goes through and installs Yarn, the required dependency, and then it runs this thing called License Finder. License Finder is the package that we use. It actually runs against both Composer and Yarn, the two dependency managers that we use for PHP and JavaScript dependencies, and it will give us that license information. So a few weeks back, I actually included a license package through Composer, and it actually failed because it used a proprietary license type that was not assigned to it. And we pay for a license for this package. So we license it on behalf of all of our customers. So it was okay. We intended to include that. But it was also okay that this failed because the system worked. It recognized the fact that this was not one of our approved licenses, and I needed to do a manual approval. I had to say, yes, this entry is okay, so that would skip that going forward and would understand this is a valid thing. So then we get to something called Cyclone DX. Have any of you guys actually heard of Cyclone DX? Got a couple people, cool. So Cyclone DX is a standard for formatting SBOM documents in a machine-readable format. They've created a number of different GitHub actions that you can download, use to create SBOMs based on different dependency managers. And that includes, in our case, both Composer and Yarn. So these actions essentially create these SBOM files, and it names them to my liking. So you can see on the left there, we have this action called checkout v4, where it goes and it creates this Cyclone DX composer piece. Then it creates that cdx.xml file. Then it goes and it runs a hash on that file. And then it actually uploads it as a GitHub artifact so that we can reference this anytime we want to look at that build. We can go back and we can see that's the dependency file that went with that particular version of the build. So all these get uploaded as dependencies so I can go back and see exactly what packages that particular thing contained. And because the customer probably doesn't want to review multiple different SBOMs for every single dependency that's out there, we combine them together using this. It's another tool from Cyclone DX that's a merge tool. So we can actually we do the composer dependencies, we do the yarn dependencies, and then we use this merge thing to squish them together into one SBOM file. And we can actually output using this tool to either a JSON or an XML format, so they're well formatted for machine analysis. But we do both, because why not, right? It doesn't really cost us anything to do it, to do them both. So now I can look at any of our PRs, and I can see the full results of this SBOM creation process. And I can see the artifacts that are created as a result of this. And if we look inside of the file that's created, we can actually see each dependency. We can see the dependencies of dependencies, which we had no insight into before. So we understand what actually makes up the software that makes up our software, and the software that makes up the software that makes up the software, right? You can see the rat's nest that kind of unfolds here. We see the description of what it is. We can see the version of the dependency that's included. We can see how the dependency is licensed. And best of all, this is done automatically for us. So I have zero manual effort involved in generating this file. Literally, the developer creates the PR like they normally would, and all this happens automatically under the hood. It's not free, unfortunately, but it's also not incredibly expensive. So on my previous slide, it actually noted that this process consumed about 3 minutes of billable time. GitHub Actions are actually billed per minute, but the different plans come with a certain number of minutes. So in our case, we use something called GitHub Team, and that comes with 3,000 minutes per month. And we had, when I ran this, when I created this presentation, we had about 9 days left in the billing period, and we used just over 1/3 of our included minutes. So it's essentially included with our plan. Now, if you're doing a lot of stuff, if you're doing a lot of PRs and things like that, maybe it'll run out. But even if we had 0 minutes left, this action would have cost us 2.4 cents. So, I mean, it might as well be free, right? So the customer-facing result of all of this hard work actually looks something like this. You can see that we've squished this all. We've removed all the color coding, the reds, the greens, all that stuff. But this still clearly defines that we had 2 manually managed dependencies left. It provides transparency with respect to the notes on those specific dependencies. It provides our standard SBOM. You can see those guys attached at the bottom. So a customer can actually consume it if they would like to. They can put it into their tools and they can run it there. So this is pretty slick, right? We get all this essentially for free, and it happens automatically under the covers. But it's not quite the end game. There's more that we can do here. What we need to do is we need to figure out, how do we use this data? How do we build on top of this? So at this point, we still have to grab the SBOM, and we have to upload it to this page to publish the updates. That is a manual process. We've automated a ton, but there's still a few things that are there. We also have to do our diligence in keeping the packages under management and ensuring that they remain up to date. So I can specify a version of a package, and if I never change that version of the package, it might remind me that that package is out of date if there are vulnerabilities in it, but otherwise it's just going to go on happily saying, yes, that's the version, until that version no longer will work with my software. So we need to make sure that we're keeping track of those versions, we're making sure that we're updating them. Now you kind of have a decision to make. Early on in this process, we used to go and we would put star as the version of the package that we would use in our composer file. And what star does for a version of a package is it says, just give me the latest version. Now, what frequently happens when we do that is every time I do a composer update, it actually updates those versions. And sometimes those are not compatible with the previous version. They remove a function. They use different features and things like that. And so we want to make sure that we have stability as we're going through this process as well. So we make sure that as we're doing this, we're specifying the exact version that we want, and then we can do testing on the new versions before we release them. We also still need to review the results that are presented to us, and we need to make informed decisions about how to proceed where security, quality, and licensing are concerned. So this is kind of a gray area. We've automated a lot of this stuff, but I'm not quite comfortable with machine-driven results, not 100% anyways. And so this is where I kind of fall back to a tool called Dependency Track. And for those who aren't familiar with it, Dependency Track is a free tool. You can use it to basically pull in these SBOM files. So it actually will do the automation of pulling in the SBOM files. And it will offer us suggestions on problems with our dependencies. So this project has been around for over a decade with the OWASP Foundation, and it consumes these files up. And the way that I do is I just spin it up in a Docker container. So it doesn't cost me anything to spin up Dependency Track. I just spin it up in a Docker container. I tell it, import the latest SBOM. And the results look something like this. This is a full list of the components, the versions, the licenses, and now I can track which dependencies are out of date. I can take this a step further, and it'll show me known vulnerabilities with that version of that software. And I can easily determine if components that we're using are impacted by those vulnerabilities. So in this case, we've actually addressed both of the vulnerabilities that it's finding on our SBOM page. I mentioned that we have that issues section where we define observations that we've made. So if somebody runs this through Dependency Track on their systems, and they go, oh, we got them, they have 2 vulnerabilities, they would look at this page and go, oh, they already mentioned these. They're already aware of these things. And there are ways to actually automate this process as well. So you can actually automatically, in your GitHub workflow, you can have it automatically upload to a Dependency Track instance. So it would constantly keep this updated. The developer creates a PR, it runs the SBOM, uploads it to Dependency Track. You don't even have to manually do any of this stuff. So lessons learned, pitfalls to avoid, strategies for success. The first bit of advice here is take baby steps, slow and steady, right? This was not a flip a bit and we magically have dependency check, dependency management, automated SBOMs. It literally took us years, and that's the reason why I took you guys all the way back to 2013, because you have to understand the problem, then you have to start figuring out how do I manage these dependencies, then go for the automation stuff. So it took us years to get here, and I don't even feel like we're done. I feel like there's still room for us to improve. The next thing is your composer JSON or package JSON or whatever you're using for your dependency management. These files are build metadata. They're information about what packages you include. Those actually could be useful to an attacker as well. In our case, it's open source, so they can download and see that kind of stuff anyways. But maybe you don't want to expose that information that you're running an old version of whatever, at least that easily. Maybe there is some value in security through obscurity. So because those files are used to determine which dependencies are included, you don't really need to provide that to the customer. So my advice is create a subdirectory under your repository and place these files in the top level of your directory. So when you are releasing code to your customer, you release the subdirectory that has your code, not all the metadata that kind of sits on the outside. I would recommend sending your dependencies to a subdirectory that is inside of that repo directory, inside of your code directory. In our case, we create a directory called vendor. And that makes it really obvious that these files are from other vendors. So if you want to see the stuff that we wrote, piece of cake. You look at everything outside the vendor directory, that's stuff that we wrote. You want to look at stuff that somebody else wrote, it's in the vendor directory. I had an interesting comment a while back. There was a guy, I think he was trying to throw a little bit of shade. The guy was looking at writing a new, I won't call it a GRC, he was writing a risk management page. And this guy posted something on LinkedIn, and somebody responded and was like, hey, have you looked at SimpleRisk? And the guy was like, oh, it's a rat's nest of code, blah, 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 I wouldn't touch that. And I started thinking about this, and I was like, okay, I'm gonna take the high road on this one, right? But I was like, hey, someday you will have all the features, all the functionality that we have, and you'll need to include other things as well. Not really a rat's nest of code. If you want to know which features come from somebody else, just look in the vendor directory. It's all right there. So even in these kind of situations where somebody starts questioning what you're doing, trying to figure out where the lines are between what you're responsible for and what somebody else is responsible for, this approach makes it very easy. The last issue here, so dependent bot only looks at versions. It doesn't look at functionality. So if there's a new version, it will suggest updating. And this kind of goes to what I said before. It doesn't know if that update, that automatic, hey, change it to this version and then run update, it doesn't know if that will break your code or not. So while you can trust Dependabot to give you suggestions, you can trust Dependabot to provide recommendations that, hey, there is a new version of that out there, test it first. It's probably good advice anytime you're doing an update, but especially in these kind of situations, if you're updating the version of a dependency, that dependency is there for a reason. They don't call it dependency because your code doesn't need it. They call it dependency because your code is dependent on it. So make sure that you're actually testing the functionality that is provided by that dependency. Now, in terms of future forecasts, I want to kind of think future-facing here. This comes from CISA. I don't know if you guys can read this. I'm going to blow it up here on mine. CISA says a software bill of materials has emerged as a key building block in software security and software supply chain risk management. An SBOM is a nested inventory, a list of ingredients that makes up software components. While not a brand new concept, the ideas and implementation have advanced since 2018 through a number of collaborative community efforts, including National Telecommunications and Information Administration's multi-stakeholder process. Talks about how CISA is advancing the SBOM adoption practices and all this stuff. So here we have a government agency that's talking about the value of doing these SBOMs. Then we go and we have an executive order. So EO 14028 defines an SBOM as a formal record containing the details of supply chain relationships of various components used in building software, similar to food ingredients labels on packaging. They hold potential to provide increased transparency, provenance, and speed at which vulnerabilities can be identified and remediated by federal departments and agencies. They can also be indicative of developer or suppliers' application of secure software development practices across the SDLC. Remember when I started out and I said, you want to be known as a leader. When you're writing software, you want to be known as a leader. This is how you do it. And then lastly, I have this NSA press release. Regardless of how you feel about the NSA, what they are telling you here is effective software bill of material management leverages identification of software components to mitigate cyber risk and support improved cybersecurity throughout the software's life cycle. According to the CSI, SBOM management should proceed in 3 steps: examine, manage the risk before acquiring the software, analyze vulnerabilities after deploying the new software, and then implement incident management to detect and respond to software vulnerabilities during vital operations. So here we have 3 different government agencies talking about the importance of SBOMs, the importance of managing your dependencies. This is going to continue. We're going to see a bigger and bigger push. We're actually seeing a lot of this coming from the US government in their purchasing process. The US government is essentially saying, if you're going to purchase, if you are going to sell to us, you must have an SBOM. You must tell us what your dependencies are. And the way that they're writing these things actually makes it so that not only do they need to provide it, they need to be aware of all the things that build into their software. And those guys need to be aware of the things that go into there. So you end up having this big chain where everybody needs to make sure they're doing an SBOM if they're selling up to the government. So the dependency storm is coming. If you want to do business with the government, SBOM will be required. All businesses doing business with the government will require an SBOM. So my advice, build an SBOM shelter now. So with that, thank you guys, and I'll take questions. No questions. Man, I did that well. No questions. Yeah.
What do you think this SBOM storm coming means for SaaS and the consumption of SaaS?
So the question for those who didn't hear is, hey, with this SBOM storm coming, what does this mean for SaaS and people consuming SaaS? I actually had a conversation kind of over lunch that alluded to this question. You know, I think that SaaS applications that expose, that are trying to be transparent about what is built into there, they're going to have a leg up. And I think even the government is going to expect that SaaS applications are tracking vulnerabilities, that they're doing dependency management, things like that. Now, it might not be done in the sense that, you know, here's the Cyclone DX file that you can run in your environment and understand everything. But I do think that even SaaS applications that we're purchasing, that we're provisioning, are going to be expected to provide some level of transparency into the issues that they're facing. And so I think this is going to be a big deal regardless of whether it's software that you're building or SaaS software. Other questions, comments? Awesome. Thank you guys. Enjoy your LASCON.